So thank you all very much for joining us here today. This webinar series and associated resources were compiled in partnership with HOK. They're really the subject matter experts and are here to talk to you about this topic today. And the resources provide guidance for architecture and engineering design professionals on best business practices, especially as the new building energy performance standards take effect in DC. But this type of information is also applicable in many other jurisdictions with building performance policies, and is also applicable when you're dealing with clients with energy performance-based goals as well. And the intent of this series is to outline from a business perspective the process to successfully embed building performance throughout a project process. Next slide. So my name is Lindsay Falaska. I'm the director of the Building Innovation Hub. I'm joined here today with our speakers, Annika Landreneau, the Director of Sustainable Design for HOK, and Donovan Olaf, the Assistant General Counsel for HOK, who are the thought leaders behind the information that you'll be hearing about today, and also the resource that's on our website as well. Next slide. So just a quick note about who we are. The Building Innovation Hub was created specifically to support the local building industry navigate new building regulations like the building energy performance standards, and support the industry to understand the changes needed in day-to-day practice. Next slide. Just a quick thank you to all of our members who help support our mission and help us expand our reach and our impact, of which HOK is one, which we are grateful for. Next slide. And as I mentioned, this webinar is the second part of a three-part series. So the first webinar, which was last week, focused on the pre-design stage, scope development, contract language based on AIA Doc E204, Sustainable Projects Exhibit, and we discussed setting expectations with the client. The webinar today will focus on the design phase, energy target setting and modeling based on ASHRAE Standard 209, defining the scope for that type of energy modeling work, and then managing the execution throughout a project. And then lastly, we have our third webinar on November 30th, where we'll focus on construction documents and administration, specifically reviewing specification language for Division 1, substitutions and RFI procedures, project turnover, commissioning, and post-occupancy consideration. So we hope if you missed the first one, you can watch the recording, and hopefully you'll sign up for the third one to sort of catch up more on the rest of the process. And with that, I will turn it over to Annika and Donovan.
Thank you so much. We're really pleased to be here. This is exciting for us. There are long-term performance commitments such as our 2030 commitment, which have really changed the rigor with which we approach performance and design and the way we practice. And this is another such a transformational sort of shift in our industry, where setting these performance targets and really looking at life cycle performance and accountability issues are going to be transformational for the practice for design and construction. Just summarizing, if you attended Module 1, we discussed some of the landmark green building codes and policies in DC. DC is the first on a lot of these, but not the last. We've seen a lot of these green codes, building performance standards, benchmarking policies replicated in community after community after community at city, county, and state levels. And so we think that it's very exciting that we get to be first, and the practices we put in place here will benefit us around the country and even around the world as our industry changes. When we define our sustainable objectives in DC, it is usually informed by several factors. It could be project size, ownership, and financing structure, and the date at which the project is anticipated to be delivered. And that really determines, are you Green Code or Green Building Act, which is related to LEED or green communities, when you start disclosing performance once the building is complete, and what BUP cycle you'll fall into. So really important issues just to determine right up front, so you know the parameters under which you'll be delivering the work. Right now, we have a series of green codes and energy codes in place. There are layering on voluntary measures that might address human health and well-being. LEED is sometimes required by the Act, and sometimes an alternative compliance path to the Green Code. And then we also have alternative compliance paths to the Energy Code, such as Passive House or Zero Energy certification. But everyone, regardless of the path you get to a complete building, has to engage in benchmarking once the project is done, and that is annual disclosure of performance, and then the Building Energy Performance Standard. So the first cycle for which you are complete and have your C of O before that cycle begins, that is when you begin your BEPS journey. So very exciting stuff.
So thank you, Annika. Just to recap a little bit of what we talked about last, I guess last Wednesday in Module 1, were the risks associated with building performance, with the compliance with building performance standards and the contractual solutions. Those contractual solutions, as you may recall, were set out in a modified E204 2017 Sustainable Projects Exhibit, and that modified document was part of the Module 1 materials. We'll refer to that today, but we won't go back through all that material. The idea with the E204 is that it's incorporated into the contracts of the owner-architect agreement, owner-contractor agreement, and we'll talk today how it would be incorporated into the architect energy modeler. So just to recap on some of the risks, right off the bat, energy compliance with energy codes, compliance with LEEDs do not guarantee that there will be compliance in the future with building performance standards. Prescriptive codes are static. The building must comply with those codes in place at the time that it is permitted. However, performance standards are dynamic. The goal behind performance standards is to drive new and existing building stock to net zero and net positive energy performance. And so you'll see a ratcheting up in the requirements of building performance standards over time. The other obvious things to look for as far as risks are that occupant behavior and other assumptions that may go into energy modeling may change in the actual use of the building. So you may have a client that moves in with a data center, a heavy plug load use. You might have a building operator who is not managing or maintaining the equipment in accordance with the contract documents or the manufacturer's intended use. So there's a lot of factors that go into how how the building will ultimately perform. And so it's a multi-party issue. Everyone has a part to play. The architect has a small part in designing it. The architect's MEP engineer and energy modeler have a small part in designing it, but the building needs to be constructed according to the contract documents and needs to be maintained and operated properly. So there's a lot of people that have a part to play, and there's a lot of variables that go into these decisions. Many of the variables in an energy model are assumed, and therefore it's important to know the limitations of relying on energy model outputs. Models are a tool for making informed decisions. They're a tool for driving energy performance to a higher level. They are not predictive of outcomes, and so it's important that we understand that and are communicating the outputs of the energy model in an appropriate way. So next slide. So what we're really here to talk about are optimal outcomes. This begins with making sure we have the right team. We have the architect, MEP engineer, energy modeler, we have the commissioning agent. All of the major stakeholders are at the table. We want to make sure that they're part of the solution. It also involves a work plan, and we discussed this in Module 1. The work plan is developed as a result of an energy charrette or a sustainability workshop. And it's in that workshop that we look at benchmarking, we establish our goals, we understand what the owner's budget, schedule, and program will support, what their energy goals are, and we try to develop a plan for addressing building performance standards in a thoughtful way. The important part of this is making sure we help our clients make informed decisions. We want to make sure that they understand what the problems are and that we're evaluating the alternatives and the benefits and consequences, and we decide on an approach and then make sure we're documenting what the decisions are. So it's really about proactive management of the project, looking ahead, setting goals, and documenting.
Great, thanks. So one big component of managing project performance and communicating is really involved in the energy modeling process. In 2019, through the 2030 commitment, which we participate in, they found that projects who use energy modeling as a component of design, and not just relying on prescriptive energy compliance with the code, were 32% more energy efficient than non-modeled projects. So just the process of measuring, they say if you can't manage what you can't measure, measuring energy performance in the design process has a substantial impact on the ability for that project to improve its performance. We also find that modeling can be really informative in cost-effective solutions for performance. We talk a lot about trade-offs, but if we can reduce peak loads through passive design solutions, we can right-size the mechanical system, for example, and then we get better performance outcomes without adding to the cost of the project. And so for a very nominal design or professional service expense, we can have big impacts on the construction budget. HOK actually did a study years ago, and we've repeated this multiple times throughout. It is published on the Department of Energy website, but we looked at the cost of energy modeling compared to the energy savings that were predicted and actually experienced in these buildings once they were delivered. And we found most of the time, the cost of energy modeling is paid for with a couple of months of building performance and the energy savings that it now achieves due to modeling leveraged in the design process. So payback is almost instant, just a couple months of energy savings and you're done, you've paid for it. Then it continues to pay for itself month after month, year after year. That's a pretty good deal. We had a couple of outliers, which were zero energy or zero carbon projects or very complex projects, but by and large, paid for itself really quickly. We published that on the Department of Energy website, and we actually heard from engineers who said, you know, you put one architect with lots of engineers through this lens. We want to try one engineer with lots of architects. And this is one of those firms, and the curve that they published, and they found that anything 25,000 square feet and up, they experienced the same thing. It paid for itself definitely in under a year. Some of the smaller projects, just because there's some effort to modeling, might have taken a little bit longer, but by and large, projects did pay for modeling very quickly. That being said, rules are meant to be broken. We have projects under 25,000 square feet where the energy modeling still pays for itself in well under a year of energy savings. These are a couple of projects we consulted on in Montgomery County, which has great incentives for advanced performance buildings. And the energy modeling paid for itself in just a few months. And these are, again, much smaller projects. So we don't want anyone to feel like this is only effective on large projects. No, we find in this region with our advanced energy goals and incentives, modeling is still a very quick payback part of the design process. This is another project on which we provided sustainable consulting, a LEED Platinum hotel right outside of Washington, D.C., and again, a 2-month payback. And so here's some larger projects. This is where we spend a lot of our time in design. This is the new National Association of Broadcasters headquarters in Southeast DC, just north of the ballpark. And so just to give you an example, leveraged modeling, the costs were paid for in 2 months of energy performance. And so what a valuable tool that is. And they see an annual energy cost savings of 26%. This is another project. It is a repositioning of an existing building in Northwest DC, just a few blocks from the White House. And you can see that they get an annual energy cost savings of over 31%, energy use savings of nearly 45%, and the energy model paid for itself in less than 4 months. So that's something, you know, the services vary. I don't want to put a price structure on what people charge for modeling, but anything that pays for itself in a couple of months and then continues to reap rewards, I think is very worthwhile. This is a laboratory we did for the District of Columbia over in Southwest DC. The modeling payback was 1 month, and the final delivered cost of this building was actually 17% under budget. Modeling was leveraged early and often in the design process to look for load reduction solutions and other solutions that help bring the cost down for this project. And let's talk about commercial development, speculative new construction, which a lot of people are undertaking. This is in Northeast DC over by the NOMA metro station. You probably recognize the ATF just south of the infamous Dave Thomas Circle. But we have this block here, Constitution Square, where we worked on 4 office buildings, 1, 2, 3, and 4. And there's also some multifamily residential. Just zooming in a little bit, and I love this picture because you see not just our energy issues, but DC's aggressive green area ratio and stormwater regulations have really driven a lot of green space at the roof plane as well. So this is a great image that represents the evolution of our green building in DC. So the first building was delivered in 2010. Window to wall ratio about 50%, concentrating mostly on the facades at the street. And this is one where the energy model paid for itself in less than 2 months. This project did not start off as a LEED project, but while we were in design, the Green Building Act passed. And our client, very forward-looking, said, I don't want the last brown buildings on the block. And so we ended up setting a LEED goal, which escalated to LEED Platinum by the time we were complete. Same thing with building 2 right next door. And this is one, again, with a less than 2-month payback on energy modeling. These were market rate speculative office buildings. So the client didn't have tons of money to throw at modeling, but it was still a really valuable part of the process and helped us get to LEED Platinum on both. As we move around the block and we get to building 3, once again, another LEED Platinum building, and we were able to get to modeling payback in less than 2 months. And then this one, which I'll mention again in a moment, but we leveraged modeling in the design process to support value engineering exercises and actually improved the performance of the building while cutting costs of construction. The payback of this energy model was instant. We didn't have to wait for the first month of energy savings in occupancy in order to pay for it. So when we talk about energy modeling, it's a very vague term. The AIA has mapped this out, this great graphic that says this is the kind of stuff that you're looking for and when, and there's some narrative that goes with it. But this isn't really great contract language. It's not standardized. And so as we mentioned in module 1, and we're going to repeat here, the architecture and engineering community came together to put together a great standard to define what energy modeling is. What are we modeling? When are we doing it? What kinds of information are we looking for? This is extremely helpful because you can better define your scope of work, what's included, what's an ad service. And then if you need to go back and pick up ad services, you can do that. But everyone really understands what's in the contracted scope of work and what is not. So we want to know what kind of models do you want? When do you want them? What kind of feedback are you looking for? Do you want workshops as part of the model delivery process so that everyone can talk about the outcome? Who should participate? And which cycles are included and which are not, so that you can add those later if needed. Now, the 209 standard has design requirements and construction options for modeling. The minimum requirements of the standard, which we'll talk about today, are section 5 general requirements, which coincide very well with our energy code and in LEED if you're in the Green Building Act. Some of those requirements for early target setting and other issues. A minimum of the load reduction modeling cycle, and then at least one of the other design cycles at your choice. We're going to recommend you pick up more than one. We won't talk about construction modeling today. That'll be in our next module. I hope you join us. But just be aware that there are additional modeling cycles that can be picked up in the construction phase. So a lot of small words here, but this is just a chart that maps out the ASHRAE 209 standard, the different types of modeling, and even the section 5 general requirements and what phase they should be happening in. So you can see some of the section, the general requirements section requirements like climate and site analysis and benchmarking comparing to similar buildings. You can see that here, and then you start to see these different cycles iterate throughout. And then commissioning activities layered over that. They work really well hand in hand, and workshops with stakeholders also. The LEED integrative process credit, which is an optional credit in LEED, aligns very well with the general requirements of ASHRAE 209 and the cycle 1 modeling, the simple box modeling. So if you fall under the Green Building Act and you need to do LEED certification, or it's your ACP to the Green Code, participating in these activities support a credit achievement under LEED. So we'll talk for a moment about the general requirements. The first is that you have simulation software that meets ASHRAE 90.1 section G2.2. This is also referenced in the DC Energy Code, so this is not something different from what you'll have to do for code compliance. There is a reference to energy model credentials, which again is also referenced by the DC Energy Code. A request for climate and site analysis, benchmarking, comparing to peer buildings, an energy charrette, which can be a broader sustainability charrette, but an early goal setting workshop, multidisciplinary, very important with your stakeholders. Energy performance goals that are articulated as a result of that charrette and included in the owner's project requirements. And that sets the stage for your energy code compliance and your LEED compliance under the Green Building Act. Both of these require commissioning and therefore require an owner's project requirements or OPR document be developed. General modeling cycle requirements. This just reviews how you establish your baseline, inputs, outputs, QA/QC, et cetera. So it's more of a process requirement. So jumping right in, this is an optional cycle in ASHRAE 209, but we strongly recommend it's a basic service. It's not something that you choose as an add-on. For one, it happens so early. But this is something that aligns really well with, again, the LEED integrated process credit and the DC Energy Code. So we think it's important. This is sort of almost a design neutral building to start with. They call it shoebox modeling as well. Should be in concept or early SD. So you start off with something that's orientation neutral and design neutral, and it's really a sensitivity analysis. What's going to have the biggest impact on performance? Is it a shift in orientation? Is it a change in window to wall ratio? Is it an improvement in R values and U values? You get to start to look at those things. Is it a change in massing, right? So you start to look at that high level. Maybe you're considering very, very high level, some different HVAC options, and you want to plug a couple things in. But this is really to say, what direction are we going to focus our efforts to have the biggest impact on energy performance? That should happen early on in concept or early SD. And then followed by conceptual design modeling, where you still have some opportunities to optimize building form. This is often conducted by the architectural design team as opposed to the engineer or a third-party sustainability consultant. In this case, we strongly recommend it as a basic service unless the building form and orientation are really already determined. We're in Washington, DC, a lot of zero lot line projects with height restriction. So the massing may be fairly set, but if you do have some opportunities to carve out a little bit, to play with the massing a little bit, or change the orientation of the project, this is a great way to look and see what the impacts of those alterations might be, again, at a very high level. Then we move into load reduction modeling. This is the most critical cycle. I can't emphasize that enough. This is your opportunity to right-size your HVAC, save construction dollars. This is what pays for energy modeling and pays for a lot of other sustainability if you get this right and you do it early enough in the design process. So load reduction modeling is mandatory in the 209 standard. This cycle focuses on both annual energy use and peak heating and cooling loads. Your HVAC system sizing is determined by your peak loads. I can't emphasize that enough. Too often the architects design a building, the peak loads are set, and then they hand it off to the engineer and say, address these loads as efficiently as you can. When the peak loads are already baked in, we lose the opportunity to actually reduce and right-size the HVAC system and save construction dollars. So this is really important to focus on peak load reduction first before you get to designing the HVAC system. So this is something that can have immediate payback. This needs to be performed before HVAC system selection if you're going to do that kind of modeling, but no later than the end of SD. Really important. So here's an example. This is the Royal Caribbean Cruise Line headquarters in Miami. This is climate zone 1, really hot, humid, really cooling load driven. So we had designed this building with slab edge extensions that would shade the windows and the building interior from solar heat gain. This provides glare control, thermal comfort, but also reduces the peak cooling loads. Really important. And you can see from concept how we played with those extensions to really shade the windows, and again, concept to what was our schematic enclosure design at that point. we were having a hard time with a client who really wanted to dial those back in order to preserve the view of the water. Now, we showed them through virtual reality that the water view was not altered, but still there was a perception that maybe they would feel ominous if they were looming out on your horizon. You know, we had a strict energy code in this jurisdiction. And so we said, here's the deal. We can either do this high window to wall ratio that you're looking for and the slab edge extensions, or if you dial the slab edge extensions back, we could reduce the window to wall ratio by 50%, or you're not going to meet code. And by the way, and this shows the load reduction or the load peak cooling load calculation side by side with annual energy. If we remove those slab edge extensions, we're going to increase your chiller plant size by 13%. We are going to increase mechanical rooms, CEP size, maintenance, all of that. So the annual energy increase is nominal, it's 5% and not a big deal, but your construction costs are going to go through the roof. And the client said, never mind, we're keeping the slab edge extensions because we like the size of the chiller plant we have, the mechanical rooms, and the equipment sizing that we have, and the enclosure design was approved. This is really important. Sometimes we do this in reverse, where we value engineer and we reduce peak loads in order to shave off mechanical costs. In this case, we were looking to avoid adding on mechanical costs, and it was effective. And then the HVAC system selection, once you have your load profiles, if you already know what kind of system you're using, you might not need this cycle. Maybe you're like, we're doing DOAS and VRF and we know it, the client's happy with it, they know how to operate and maintain it. We're not going to get too exotic, great. But if you're not sure, if you do want to look at a couple different options, let's say ground source heat exchange or a radiant system, and you want to look at different options compared to maybe what your baseline is, this is a cycle of modeling that allows you to plug in your options and see what their impacts on performance would be. And again, really critical that you do this after your load reduction and your load profiles have been determined. So recommend this as an ad service if you're not sure if you're going to need it. If you are sure you're going to need it, then go ahead and include it in your scope. So the next cycle is really design refinement. And we recommend that this isn't a one-time model. Maybe you're doing this for the end of SD through 50% DD, but this is probably a couple of iterations. And so this is something where not only should there be iterations, but meetings to follow up and discuss outcomes. It can be a phone call. It doesn't need to be an all-day workshop. Design refinement is really applying people and space program to the building. So we understand who's using what space and where, how is it partitioned, what are the use types of these spaces. You're also looking at the enclosure refinement, facade optimization, maybe shades and louvers and things like that. An example here with program refinement, this is the DC Consolidated Lab I mentioned earlier. Our Office of the Chief Medical Examiner, or morgue for the district, has the highest air change rate requirement of any of the spaces in the building. Because of that, it will drive fan energy significantly as one of the major energy end uses of the building. And so we moved it to the top floor in order to be closest to the penthouse and shorten the duct run and therefore reduce the fan energy required for the space. So that's an example of how in the model, you could say, what happens if I make this move? What's the impact on energy? And it can inform how program is organized in the building. As well as you get around to the enclosure, here we put the labs on the north, indirect light. Because they were all in the north, we were able to raise the sill height to bench height and get a good window to wall ratio there. On the south, we had all of our offices. We were able to do much taller glazing and view, but controlled with a louver facade. And that's one that actually shifts based on sun angle and time of day or weather, barometric pressure. And then did really deep set narrow windows on the east and west to control that lower sun angle. And then again, starting to layer in systems. We did chilled beams, energy recovery ventilation, heat shift chiller. All of those things added up to load reduction, system right sizing, reduced floor to floor height for the chilled beams, and help bring this project in 17% under budget. Energy modeling was really crucial to that construction cost savings. Then you sort of move into the next stage of modeling where we're looking at design integration and optimization. So maybe we're folding in some operations and maintenance protocols, setbacks, expanded set points, demand control ventilation or lighting. We also may be looking at subsystems, not the high level systems, but the smaller systems that support those main building systems. This is an example of an inpatient mental health care hospital for the state of Oregon. Strongly recommend this cycle as a basic service because all of us do have to layer in all of these systems and subsystems and should be talking about O&M protocols in the energy modeling process. This is a big part of helping buildings achieve not just the energy code, but BEPS later on and keeping buildings on track to perform the way they're intended. So as we layer on enclosure materials, glare control, et cetera, but also look at those O&M issues, then we are able to see what the impacts are. In this hospital, we had a very, very tight budget. This is tilt wall construction, but we were able to do a very tight enclosure, limited window to wall ratio. We did use chilled beams, which helped reduce floor to floor height. And we were able to get the loads so low that we could take on all of the heating and cooling through a ground source heat exchange well field, a geothermal well field. Also, we're able to leverage things like daylighting, night flushing for certain spaces, expanded temperature set points, and energy recovery ventilation. Most critically, we had demand control ventilation lighting in patient rooms and found that their occupancy spaces outside of their own rooms was much higher than expected. And this building actually performs at half the predicted EUI that we had in the energy model. So we predicted a 90 kBTU and it's performing at 45. So this is, tremendously helpful. We had to predict occupant behavior. It did not go the way we thought it would. They're not in their rooms, which is great. They're participating in activities. So this actually went in the right direction where the building performs far better than anticipated in the model. So this again is an iterative process, and we want to see that potentially at the end of DD and going into CDs. But layered on top of that, you may have something called simulation aided value engineering. So these don't have to be consecutive. They can be the same cycle or can be concurrent. But simulation aided value engineering is about cutting costs. We always know that's a priority while still maintaining performance. And I mentioned this project earlier in this module. This is a project where in design development, our mechanical package was over budget. The cynic in me said we're probably going to end up with a less efficient mechanical system. But ultimately, we were able to make an adjustment to window to wall ratio. We were able to reduce it just a tad and then choose a better performing glazing system, but less of it, and reduce the peak loads enough to get rid of a chiller. And that ended up coming in at a net savings to the project. We were able to do that in the design phase and design development. The EUI, the predicted EUI went from 32 kBTU per square foot per year down to 28. So we did not lose performance, we improved performance while we were value engineering. That is why simulation aided value engineering is so critical. We did bring the cost back on budget, but we also improved performance at the same time. So this is an important cycle. It can be a basic service or it could be an ad service as needed. And then as designed energy performance. This is basically your code compliance model, your lead documentation model. This is the thing you do at the very end of CDs, essentially. You're either submitting it, for your permit or with your lead documentation package. So this should be a basic service because we're all going to need to submit an energy model with our energy code documentation for permit. And DC also has some great energy code inspectors who will make sure that what got built on the job site matches what you had in your model. So the cycle of modeling necessary to demonstrate code compliance, it's lead documentation. This is not a design feedback model. Too often, some projects don't see their first energy model until they're getting to their compliance documentation. And you don't have the opportunity to go back and make changes to the design if you wait till the end of CDs to get your first energy model. This is not intended to give you any sort of information to plug into your design process. This is just a compliance model or documentation model. This should not be the only model that you have, but too often this is what people contract for. This is a waste of your money, frankly, if this is the only energy feedback you get at the end of the day. You should be getting a lot more value out of your energy modeling process. So briefly want to talk about tools. This is the overview that we just went through of modeling process and all of the different iterations of modeling and at what stages of design. But what tools work at each of those stages? Well, when we talk about conceptual design modeling, particularly for designers, things like Open Studio, Ladybug Tools, or Climate Studio are all really good options. Climate Studio does require a license, but Open Studio and Ladybug Tools are free open source software. So they're all great options for the design team to look at optimizing performance at the conceptual design stage. As we move into schematic design, if you're working in a BIM tool, such as Revit, there's an Insight 360 tool, which you can look at the early design and the idea of different mechanical systems. It's not a designed system, but am I looking at VRF? Am I looking at, radiant systems, et cetera? And you can get an early sense of energy performance feedback in the architectural design software. When we want to fold in engineering systems as well, we strongly recommend IES. You can export your BIM model directly into the modeling software, and it's a lot quicker and I think more accurate. We use this for that Royal Caribbean project I showed earlier that had very complex geometry. Would have been challenging to do this in some of the tools that are out there for modeling because of that geometry. So there are free software tools. IES does require a license, Energy Plus and eQuest. Energy Plus is better for projects maybe with higher performance ambition and more complex systems, but takes a little bit longer to run. eQuest is faster, but it's also faster because it is simplified. And I'll go through that in just a minute. So at the sacrifice of maybe accuracy if you're trying out different advanced design techniques. And then ultimately you can maintain these tools through CA if you're making changes to the design in construction, substitutions, change orders, what have you. But all of these projects should roll into some kind of tracking tool such as Portfolio Manager for reporting back to DC, for benchmarking and BEPS. But clients sometimes have their own software tools they like to use for their portfolios as well. I'm not going to go through this in great detail, just to say that there is research that compares Energy Plus and eQuest side by side, both great tools, but pick the right one for the job. eQuest is faster and better for simpler buildings. If it is a code minimum building following the prescriptive sort of design approach, it works very well. If you are using a higher performance design approach and you want to look at more nuanced design solutions, including more passive design solutions, Energy Plus is going to do a better job of reflecting those performance improvements accurately. Again, it takes a little bit more time to run because of that, but you get better and more accurate results. So it's really about what kind of project you have and what's the right tool for that. And Donovan mentioned some things that impact actual performance compared to modeling. I just want to note that there are measures you can take in the design process, knowing that those are factors. And so things like occupant behavior, you can put in different kinds of sensors and controls to help mitigate the impact of occupant behavior. But we highly, highly recommend A, that tenant spaces are submetered, and B, that owners consider green leasing so that there is some responsibility on the tenant side to manage energy consumption and performance. Submetering is very important, advanced energy metering, but for at least the major loads in the building so that you can identify problems more quickly and hone in on them. I would also go further to say fault detection and diagnostics included in the 2021 IECC is another great tool so that you see problems coming before they become problems and you're able to address them. O&M, operations and maintenance, having good plans in place and for training, and not just once, but iterative training every 18 months, every 2 years, we get turnover and staff, but really important that if you have O&M personnel that can join the design process, that they are engaged. Really important also to look for experienced building enclosure commissioning and support and ensure that all of the steps in both mechanical, electrical, and enclosure commissioning are taken to manage design quality. And then, of course, in construction administration. And then if there are changes in use or occupancy from what you included in your initial energy model, Make sure that model is able to be updated later so that you get an updated expectance or anticipated performance through modeling. And I won't go into a lot of detail about commissioning, but I've mentioned it a few times. I just want you to know that the DC Energy Code requires mechanical electrical commissioning for projects 10,000 square feet and up, and enclosure commissioning for projects 50,000 square feet and up. So those are layered in here. If you layer those in, they can support your performance tracking and design as well as construction, and you will meet the code. And by the way, you'll also be able to get some LEED credits for those things. So here's the code language, the 2017 DC Energy Code. Note that DC requires a true third party for commissioning authority, not a disinterested member of the design team. And the other thing I'll note is the enclosure commissioning required by our energy code has two pathways. One is waiting till the end of construction and doing whole building air tightness testing, but you don't know you have a problem till the end of construction. Two is engaging a consultant in design phase and having peer reviews of the design packages and assembly testing and inspections on site. So make sure you get that person engaged in design development if that is your process, rather than relying on the whole building air tightness testing. If they are not involved early enough, then you cannot use this compliance path. So we have an outline of this process and who does what: the owner, the commissioning agent for energy systems, dynamic energy systems, and the enclosure. This is really important. The enclosure is the first line of defense. So I'm glad that enclosure commissioning is in fact now a part of our energy code. So just to note that we can't predict the future. We hope the goals are to do well through a certain number of cycles for BEPS. Right now, BEPS is established at median Energy Star scores, local median Energy Star scores, or national median source EUI, depending on the building type. And that means they're going to change over time. The year before BEPS was put into effect, these were some of the median Energy Star scores for building types. And then the next year when BEPS was selected, these were the median Energy Star scores. Commercial buildings got better, senior care got better, retail supermarkets got better, hotels got better. Some stayed the same, like multifamily and K-12 schools, and some building types got a little bit worse. We really can't predict the future. Things could escalate very quickly now that we have a new energy code in place in BEPS. But just to know that past performance is not necessarily going to help you predict. So it's a good idea really to leapfrog past the minimum performance requirement and target an energy performance that will keep you safe.
So thank you, Annika. That was really interesting. Okay, so I want to talk a little bit about how do we deal with some of the risks that we have with consultants. In particular, we're going to look at contracting for services with our energy modeling consultants. What I want to do is take the ASHRAE 209 process that Annika visualized through the initial presentation and condense it down into contract language. We're going to use the C401, which is the standard form agreement between architect and consultant. And then we are going to use what I call Exhibit A, Energy Modeling Scope of Services. This is a document that HOK has developed. A few quick caveats about the contract language. The language that we're talking about is neutral, as it was with the E204 in Module 1. I will try to point out how this neutral language applies to the Clean Energy DC Act as we go through it. But the other points that I want to make is that the modifications to the standard AIA contracts are, of course, not approved by AIA. This is just to really illustrate how you might contract for these services, but they're not necessarily approved by AIA. Also, that HOK language is not, of course, legal advice. It's how we deal with some of this risk, but of course, every project is different. So if we could go back real quick to one slide, there we go. So the modifications to the C401 are really simple, as everyone who uses this document is familiar. The consultant scope is always referred to this portion of the project. What we want to make sure is that this portion of the project refers to the Exhibit A that we'll talk about, which is the energy modeling scope that we've developed. And then the next slide, we'll look at just another couple of documents we want to make sure that we incorporate by reference. The modified E204 that we discussed in Module 1. There are some important limitations, expectations, processes that are built into that document that would need to be part of this document as well. And also, of course, our Exhibit A energy modeling consultant scope. So let's talk about that document. So the first thing that we'll look at are some of the definitions. This is a little bit of a recap on the discussion that we had with the E204, and essentially what we've done here is pulled those same definitions into this document. So we have building performance standard, which of course under the Clean Energy DC Act means the local median Energy Star score or energy use intensity, depending on the project type. And then of course, building performance standard is the baseline energy performance required by the authority having jurisdiction, which in the context of the Clean Energy DC Act is the Department of Energy and Environment. Building performance target is that target that will be developed through the Energy Charrette or Sustainability Workshop that will establish the level of energy performance that the project is targeting to achieve compliance during the compliance period. So I think we have one more pop-up there. And the compliance period is the important piece of all of this. It's what we really see as the critical discussion point on helping our clients make informed decisions. And the compliance period, we want to make sure that we're stating that in the number of years. Perhaps 10 years to match the statute of repose in DC, but be aware that the statute of repose changes from state to state and may not exist in some states. But at any rate, what you'll have is a conversation with the client during the sustainability workshop to make sure that you set the period for which the building will achieve compliance with the building performance standards. There needs to be a horizon on this, unless you're designing net zero or net positive energy performance. There needs to be a horizon on the duration that the project will achieve compliance. And the client needs to understand what that means, what that horizon means. After the compliance period ends, improvements may be required to the building to continue to comply with building performance standards. And then of course, the sustainability workshop is that pre-design meeting where we set all of the goals, we set the building performance targets, we set all of establish all of the criteria that will go into energy modeling. Under ASHRAE 209, it's referred to as the Energy Charrette, but it's a very important part of this agreement because we really believe that the energy modeler plays an important role in that process. So next slide. Pop up here, and as Annika mentioned, the ASHRAE 209 is a cafeteria approach. And what we've done here is allowed the user of this document to select which model cycles will apply. And of course, model cycle 3 is required, as are general conditions, and at least one other design model cycle. What we've sketched out in this document is the process that Annika discussed today. So it's quite a bit more than the minimum requirements, but just wanted to make sure everyone understood that at minimum were those 3 requirements. So next, yeah. So a couple of additional, in addition to the model cycles that are required, it is ASHRAE 209 requires completion of the general requirements in section 5 of ASHRAE 209. But we've also added other general requirements that we believe are important. We can pop them up here. those general requirements include making sure the energy modeler coordinates with the architect and its consultants on required design elements for building performance compliance. We want to make sure that there's coordination with the owner's commissioning agent. Also, it's really important for the energy modeler to facilitate meetings related to the energy modeling work plan, which we'll talk about in a minute, but really anything related to energy modeling is in the realm of the, or the responsibility of the energy modeler. Next slide. A few more general requirements. We want the energy modeler to be familiar with the owner's program, budget, and schedule. These are important limitations that may restrict what can be done. And so we want the modeler to be, the modeling consultant to be aware of what those limitations are, and then to advise us on any decisions or changes to the project that may impact those criteria. We want the modeler to review the drawing specifications and other project documents to be completely familiar with what's going on in the project. And then also we want energy modeling that's consistent with of course, the building performance standards, the target, and compliance. And then, of course, keeping the architect informed of important changes, whether they're to the owner's program, budget, and schedule, or changes to the project that may impact any of those. We want to make sure we're kept informed. The next slide. So pre-design is important. We've pushed the sustainability workshop into pre-design. I know in the E204 it contemplates that it would happen before the end of schematic design, but because of some of the requirements that Annika talked about under ASHRAE 209, we believe it's important to happen before we begin the design process. And we want the energy modeling consultant to really lead on some key criteria. Identifying important climate and site analysis, of course, benchmarking energy use of the building peer group, making sure we understand which performance standard is in place now and where we think the performance standard will be in the future, so that the appropriate performance target can be set. It's also important for the modeler to be part of the discussion on the compliance period. And helping the owner to understand the impacts of setting a compliance period that is, perhaps 10 years, 5 years, something shorter than the life cycle of the building. And so, there are a number of criteria that we want the modeler to help us with. Next slide. And then, of course, the modeling work plan. So a lot of the things that we just talked about on the prior slide would be discussed and determined in that energy charrette or the sustainability workshop. And the work product for the modeler from that workshop is, of course, the energy modeling work plan. And the energy modeling work plan really sets out the compliance period, the performance targets, the measures that will be undertaken to achieve compliance, other implementation strategies. We also want to know which model cycles are being run and how often and when, and then when reports are due, as well as what are we doing to make sure that compliance is being achieved at each design phase. And then, of course, we'll see this as we go through each phase to the extent that it's identified as a basic service in that chart that we showed earlier on an earlier slide. We want to make sure that the energy modeler is obligated to run the model cycle. So in pre-design, it would be model cycle 1, or the sample box modeling, or the conceptual design modeling. And again, this is not prescribed the way that it absolutely has to be. This is always going to be flexible and adaptable to your project, but just using the visualization that Annika set out earlier, we tried to capture it in this document. So in every phase really has some key performance requirements. We want the energy modeler to take a look at the prior reports from the prior phase and to adjust the work plan as necessary if there are adjustments that are needed to continue to achieve building performance compliance. We want to update the model with any additional outputs, and then of course perform the model cycles that are appropriate during that phase, whether it's load reduction or the HVAC system selection or design refinements as identified in schematic design. We want to make sure that those are being carried out. The other important thing to keep in mind is at each phase, the energy modeler will prepare a report and then will facilitate meetings to make sure that people understand what is in the report. Contract documents, again, we're looking at what was the last report for design development, and then making sure that we're running the cycles that are basic services during that phase, whether it's integration or value added or as designed energy performance based on the 100% contract documents. And then, of course, facilitate a final energy modeling meeting at the end of construction documents and prepare a final report. And then during construction, many of these might be add services, but to the extent they are basic services, we want to make sure that the energy modeler is running, assistance with value engineering, an as design model, or making other change order modeling as changes, substitutions come up during the course of the project. We want to make sure that those are being modeled and we're understanding the impact on building performance. As you recall, in the E204, we had restricted the contractor from proceeding with any change that impacted a building performance target or building performance compliance unless they received written direction from the owner to do so. And so during post-occupancy, again, a lot of this might be additional services, but to the extent they are basic services, making sure the modeler is performing post-occupancy energy performance comparisons, and then, of course, notifying the owner and architect of any deviations between the designed performance or the as constructed performance and a building performance target. So if it looks, after doing a as constructed model analysis that building performance standard is being impacted, it's important for the owner and architect to understand that and for variations to be and adjustments to be made to make sure that compliance is achieved. Okay, next slide.
Yeah, so just finally, some recommendations for best practices. Definitely make sure you're including both MEP and enclosure design components in the scope for modeling. Also, highly recommend lighting power density, that you're using a space-by-space method rather than building area method. You'll find more opportunities for savings. The codes are getting more aggressive with lighting power anyway, but there's still opportunities to do better than code. We have recommendations for software in this order. IES is hands down, we find the best tool for modeling whole building, architectural design, and MEP design solutions. It is easier to transfer your BIM model to the modeling software and kind of do it concurrent with design without long lag times between design and then model. So more responsive. But if you want to use one of the free software solutions, our next recommendation would be Energy Plus. It is free. It is better for advanced energy targets because it will model a lot of those different design solutions where eQuest is faster, but not going to be as accurate. They're all good tools, but this is our recommendations in order of what we find to be most effective as accurately reflecting performance, but also supporting design decisions. We highly recommend you include in your scope a workshop or meeting after each model iteration. Could be a phone call, doesn't need to be an all-day workshop, but discuss the report and the outcomes and discuss recommendations. How are you going to improve upon it if needed? In most cases, we find both with the code and with Hvac, we do need to improve upon the information we have. Sometimes it's getting more details about the design, but a lot of times it's looking for those design amendments that will improve the performance. Ultimately, this isn't just about liability and risk. This is about better design outcomes, better performance outcomes, and we really want to use the model for that. And then finally, that there is a final for each phase, energy model report and meeting required before that phase is closed out, before a consultant is paid 100% for that phase, that final deliverable and that final meeting is held before you consider their scope of work for that phase closed out. That way you can make sure that it happens, and it's a really critical step. And with that, I know we're just a couple of minutes over, but we're happy to take a question or two if anyone has got something burning on their mind.
Greatly appreciated. And I appreciate the framing at the end where obviously we're talking about this in terms of risk and liability, but I appreciate that it's really about enabling people to create better buildings, which I think is the crux of it. I actually have one question, which is specific to the fact that the early stages of a design process, architects might not have a sustainability consultant or MEP on board. And so you referenced OpenStudio, Ladybug, and Autodesk Insight as tools to use. Do you have any recommendation for architects on how to get comfortable with those tools and be able to feel comfortable enough to actually present them to a client? Just sort of general questions about how to get people comfortable speaking the language of energy models when they might not have an expert on board yet.
There are tons of YouTube tutorials. LinkedIn also has LinkedIn Learning. There's tons of educational tutorials. Within the firm, if you've got any good users, having them record some short instructional videos showing how they're using it on an actual project the firm is designing is always better. But there's plenty of tutorials out there that are free. And then I would say, the best way to learn is to apply, like actually get familiar with the tool and then start using it. But question your results every time until you feel like you're a very experienced user. Does this look right? Would my gut tell me that I should get a different response from the tool or output from the tool? Because if so, let me go back and check my inputs and let me check my parameters and make sure I did everything properly. Don't just share information with the client. If you're not comfortable that it's accurate, make sure you go back and quality control your work.
Do you make any adjustments to your BIM or Revit model in order to use Autodesk Insight or the IES integrated tool? Do you model any differently?
Well, you do. For any of these tools, it's important things like the walls connect. One of the biggest challenges we have with the modeling tools is sometimes we get a quickly constructed Revit model or something, and there's gaps. There's gaps in the walls, and the model reads that as holes, and the building is leaking. And so the quality of the model greatly impacts the performance the model is able to reflect. And so some folks are using these models to sketch early designs and aren't tightening up all those things. And it can sort of inaccurately show poor performance because it thinks the model's leaking. So that's the one tip I would say is, the change in modeling practices is to get better about making sure like the walls and ceiling or walls connect. But other than that, the Insight 360 is included with the software, I believe. You just have to install it, but it's not like an ad. I don't believe. I think it's just something you have to install.
One more question for me. One of the things that DOEE references quite a bit is Energy Star Target Finder for folks to use to be able to understand potential Energy Star score throughout design process. Do you have any recommendations of when people should start that or how they should be thinking about the process of integrating that into their process?
Every time you have an energy model report or output, you basically take that information, how many kWh or BTUs is the building predicted to use over the course of the year. You can go to Target Finder, it's free, just Google Energy Star Target Finder. And then you input the building size and program and location, and then you input that predicted energy use. And it will give you a Target Finder score. And it says, we predict if your building performs the way you have told us it will, this would be, you would have a 89 or a 95. Now, once you get an updated energy model and updated energy use information, go back in and change it. You can save your building in Energy Star. So you don't have to redo everything. You just change the energy consumption numbers each time you have a new output. So that's helpful. And it's also helpful to submeter things like your building garage. If you have a high energy intensity space like a data center or retail, it's important to submeter those because when you go back around into Portfolio Manager, you'll be able to break out energy consumption by use type and get a better score for that as well.
Awesome. Well, since we are over time, I just want to thank Annika and Donovan for giving us this really detailed insight into not just the energy modeling process, but the contract provisions to sort of make all of that happen. I think it's really insightful to show how it can be baked into the project process and that it's not a cost. And I think it's a value. And so I think as we start to translate those terms while speaking to clients, it'll start to resonate. And I appreciate the precedents and case studies that showcase exactly how that has happened, especially in your work. So thank you guys very much for attending. We will look forward to our next presentation on November 30th, where we'll be talking more specifically about construction documentation and administration, looking at commissioning, specs, RFIs, and everything fun that happens during construction. So thank you again, greatly appreciated, and we will talk to everyone soon.
Thank you.
Thank you.